Western blot. In a Western blot, you use a secondary antibody, which recognizes a primary antibody, which, in turn, recognizes a protein of interest from a mix. Since the secondary antibody is marked, by seeing this mark you are indirectly identifying the protein. Because the protein comes from an electrophoresis process, first you have to transfer it from the gel to a suitable membrane in order to perform these antibody reactions. After the proteins have been separated by electrophoresis, the Western blot technique allows us to identify one protein of interest among others that migrated through the gel. For the Western blot, you will need to transfer the proteins from the electrophoresis gel to a nitrocellulose membrane. Then use two different antibodies, the primary antibody, which specifically recognizes a protein of interest. Our primary antibody will be a monoclonal antibody against our target protein, alpha-tubulin. This antibody was produced in a mouse. The other antibody is called secondary antibody and specifically recognizes the primary antibody. For this purpose, the secondary antibody must be directed against the IgG of the host where the primary antibody was made, in this case against mouse IgG. In this technique, the secondary antibody is linked to a molecule that can allow us to detect our protein of interest. Usually this molecule is an enzyme or fluorophore. In this activity, you will use a secondary antibody conjugated to a peroxidase. This enzyme will react with the substrate to produce a chemiluminescent precipitate. So, to visualize it, you will expose an X-ray to film the membrane, and afterwards you will develop this film. Let's see how we can detect alpha-tubulin protein. The aims of this activity are to transfer the proteins that have been separated by electrophoresis from the gel to a nitrocellulose membrane, to incubate the nitrocellulose membrane with the antibodies to identify the presence of our protein of interest, to detect the labeled protein using chemiluminescence. The solutions for this activity are 2000 ml of transfer buffer, 15 ml of Ponceau red solution, and 15 ml of 1 times PBS, 3 ml of primary antibody solution and 3 ml of secondary antibody solution, 15 ml of blocking solution and 90 ml of washing solution, 2 ml of chemiluminescent kit solutions, solutions A and B, and 50 ml of triple distilled water. The materials for this activity are transfer chamber, transfer container, power supply with cables, polyacrylamide gel with the proteins, nitrocellulose membrane, 2 filter papers, 2 sponges and 2 blotting pads, washing containers, orbital shaker, plastic sealer and bags, P1000 micropipette and tips, tweezers, scissors, Eppendorf tube protected from light, gloves, paper towel, cassette, aluminum box, X-ray film, film developer, and a dark room. Do all of your work in this activity with gloves. To transfer the proteins to the membrane, you must form a transfer sandwich. From the outside, this arrangement has 2 blotting pads, 2 sponges, and 2 filter papers on each side. The central materials are the gel with the proteins to blot and the membrane. Place the gel on the back side of the pad and the membrane on top of the gel. As you can see, all the materials in the sandwich must be wet. Close the system. Put it into the container and then into the chamber. Fill it with transfer buffer. Connect the electrodes of the apparatus to the power source, with the plus pole to the red end. Turn the power on. Set the transfer at 200 mA. Run the transfer for 30 minutes at room temperature. Turn the power off and take out the sandwich from the chamber. Open the sandwich. Carefully grab the membrane. Transfer efficiency can be determined by staining the membrane with Ponceau red in the following way. Wash the membrane 3 times with distilled water in a container. Incubate the membrane in an orbital shaker with Ponceau Red for 5 minutes. Rinse the membrane several times in distilled water until you can clearly see the transferred protein bands. Finally, wash the membrane with 1 times PBS. Incubate the membrane with 15 ml 1 times PBS, 3% skim milk in an orbital shaker for 30 minutes at room temperature. Put the membrane in a plastic bag made with the sealer. Seal it completely. Then, with the scissors, cut a little hole to introduce the tips of the micropipette. Add the primary antibody into the plastic bag with a P1000. Seal the bag. Incubate it in an orbital shaker at room temperature for 60 minutes. Cut the bag and discard the contents. Grab the membrane to a container. Wash it in washing solution in a shaker for 1 minute at room temperature. Wash 3 times. Place the membrane in a new plastic bag. Seal it. Through a hole, add the secondary antibody with P1000. Seal the bag and incubate under the same conditions for 30 minutes. After cutting the bag and discarding the contents, place the membrane in a container and wash it in washing solution. As before, wash 3 times, 1 minute each. To detect the reaction, you will use a chemiluminescent reagent. The product of this reaction generates light in the presence of hydrogen peroxide. For this purpose, add 1 ml of solution A to the light-protected tube with a clean tip. Use a new tip to add 1 ml of solution B. Mix both solutions. Take the membrane and add the mixture of solutions A and B on top of the whole membrane. For 1 minute, incubate it with the aluminum box that protects it from light. Drain the excess solution from the membrane onto a paper towel. Place the membrane between 2 plastic sheets. Place the plastic sheets with the membrane in the cassette. In a dark room, take 1 X-ray film and put it into the cassette. Expose the membrane to the film for 1 minute. Place the film in the automatic machine. Wait for it to come out after being developed. While working with gloves, form the transfer sandwich by placing the membrane and the gel next to each other. Connect the electrodes and run the transfer. Test the efficiency of the transfer with Ponceau Red. Incubate the membrane with the primary antibody and the secondary antibody. Incubate the membrane with the chemiluminescent reagent. Expose the membrane to the film.